All right, today we're doing 9.5 angles on the coordinate plane. We start here with this wheel of algebra. So we're going to look up here at one of these unit circles and talk about it. So here we start with 0 degrees or 360 degrees. If we go straight up, we have 90 degrees. We keep going here, 180 degrees. Keep going down, 270 degrees, and so on. So if we look at where these degrees are, again, at the beginning we start at 0. We end all the way around the circle at 360 degrees. Here we have 90 degrees. Here we have 180 degrees. 270 at the bottom. Now, if we look at these wedges, this divides it into 1, 2, 3 sections, which means if we start at 0 and we go to 90, 90 divided by 3 is 30. So the first wedge is 30 degrees. Second wedge is 60 degrees. 90 plus 30, 120. And we'll just keep going around. All right, so there is one way to interpret this unit circle. We'll divide it into more. We've got 45-degree angles we'll talk about later. For now, we're just going to talk about it divided into these 30-degree segments. Now, they run this theme through this wheel of algebra example, which doesn't make a whole lot of sense. So we'll just talk about the unit circle in the coordinate plane. As we can see here, right, our coordinate plane. For instance, this first question talks about this student Tara wanting to win lunch with Miss Gallus. And they just come up with the fact that she spun the spinner 150 degrees. So we're just going to talk about 150 degrees. So again, 0 degrees starts here on the positive x-axis. This is 90 degrees. All the way here is 180 degrees. So if we're trying to get to 150 degrees, that's that last third wedge right here. So when we draw this angle, we're going to draw it like this. We have an arrow. This is 150 degrees, and we'll go ahead and do that now. Make my pencil a little bit bigger. So we start here with the initial side, and it's going to end about right here, 2/3 of the way through quadrant 2. Again, we have this arrow, which we'll draw in. That's 150 degrees. This right here is called the initial side. The beginning of the angle, the initial side. Where the angle ends, over here, is called the terminal side. This angle, the 150 degrees, is said to be in standard position. We'll talk about more about that later. So we have the initial side here, terminal side where the angle ends. We draw an arrow which shows us the direction of the angle, right? Positive angles go counterclockwise, negative angles go counterclockwise. So we'll get on with that a bit later as well. So we have number 2 here, which talks about Tara spinning 510 degrees. So if we spin 510, we're going to go 360 around, right? And then if we think about 510 minus 360, that's 150 more degrees, and we're going to end up with the angle in that same spot we had from the previous problem. So we'll go ahead and draw that in. So again, we're starting here, the initial side at 0. And we're coming around all the way. There's 360. And we stop about right here. And we can draw that angle back to the origin. And then we're going to label that angle 510 degrees. So we arrived at that 510 degrees, or we knew where the angle was going to end up by doing 510 degrees minus 360 degrees. So we get 150 degrees. So that's how we knew that the terminal side of that angle was going to be right there. Moving on. Number 3, if you land on a starred line, again, there are no starred lines, it's okay. Jacob spun 170 degrees. How many degrees was he from getting an extra spin? I guess maybe this negative x-axis is our starred line right there. So we're going to just draw in 170 degrees. So if we think about this, again, we start at 0. If we go all the way over here to 180 degrees, 170 is going to leave us just with a little sliver above that negative x-axis. So we'll start here at positive at 0. And then we're going to end just above the negative x-axis right here. And then, so how many degrees? What they're asking for here is they want to get this distance from here to the negative x-axis. So if I'm 170 degrees, that leaves me 10 degrees left. And that is what is called our reference angle. So a reference angle talks about the distance from the x-axis. Right, so distance from the x-axis, if we were down here and we were at 190 degrees, it would still be 10 degrees as that reference angle. So even if we're down here in quadrant 4, we'd be at 350 degrees, we'd still have 10 degrees as our reference angle. So we can go back either to the positive x-axis or negative x-axis to come up with our reference angle. All right, Allie was 70 away from winning an extra spin. So we're going to draw in a 70-degree angle. So when we divide it into thirds, right, this first dot would be about 30, second dot would be about 60. So 70 is going to be somewhere kind of right about in here. We can continue to draw that line down to the bottom. So there's our roughly 70 degrees. And then if we think about this, if we do 180 degrees, right? So our 180 is over here, and we subtract 70. We're going to get 110 degrees. So we started with 70 degrees from here. And we're doing 180 minus 70 to get 110 degrees. So if we think again about from up here, where we had our unit circle divided into 30-degree increments. And we want to figure out where 110 is. Our first dot after 90, when we added 30 degrees, was about 120 and then 150. So 110 is going to be a little bit inside of that. So then we can draw that line in and try to go through the origin. And then we can label here. So we can think about doing 180 plus 70, which is going to give us 250 degrees. So these are our possible answers. So Allie was 70 away from getting an extra spin, so getting back to either the positive or the negative x-axis, that reference angle being 70. So the last one we can come up with here is doing 360 minus 70, which gives us 290 degrees, right? And still gives us that reference angle of 70 degrees here. So what they're kind of left out for us is telling us that the extra spins, like these were the starred spots on their little spinner chart. Okay, moving on to number 4. So Reed broke the rules and spun clockwise instead. He spun 35 degrees clockwise. So he started here and spun 35 degrees clockwise, right? 45 degrees would cut the quadrant in 2 equal parts. So 35 would be a little less than that. So if we're looking, right, about here would be the middle, and then 35 degrees would be a little bit less. Okay, so this, again, that reference angle up here would be 35 degrees. So what is this angle measure if we take this angle and we go this way? What is that angle going to be? Well, we can figure that angle by doing 360 degrees minus 35 degrees. And we end up with 325 degrees. So Reed spun, broke the rules, spun this way, got 35 degrees, right? Our reference angle. Then his buddy followed Nick and spun the correct direction, right? And that follows our red arrow around here. And then to figure out what, I forgot the 5 here, 325 degrees. So we figured that out by doing the 360 minus the 35 degrees, come up with that 325 degrees. Okay, next, number 5. When Samra went, the spinner point landed 2 centimeters right, 3 centimeters up. So 2 centimeters right. So we're starting here, 2 centimeters to the right and 3 centimeters up. Gives us the angle theta, always originates from the origin. You draw theta with a little circle and a line through. Okay, so the rest of this question says, so this obviously makes this a right angle. What angle did Samra spin? So we're trying to figure out what theta is. So we can use right triangle trigonometry to figure that out. And we want to think about what 3 is as it relates to this angle theta. So theta is across, right? So we're thinking about our SOHCAHTOA. We'll just write it over here. So if we're looking at our 3 centimeters, we are opposite, and then the 2 is adjacent. Remember, this is the hypotenuse, so that's not within this. So we have opposite of theta and adjacent to theta, so we're going to use tangent to figure that out. So we're going to say tan of theta equals opposite. The opposite side is 3. The adjacent side is 2. The only way to switch places with theta and this fraction is to do the inverse of theta, or the inverse of tangent, I'm sorry. The only way to switch between theta and the fraction is to do inverse tangent. So you may or may not remember, you write tan negative 1 of 3/2, and then that will get us theta. So I'm going to bring up the graphing calculator here. So a couple things with the graphing calculator we have to do. We have to click mode. We need to make sure that we are in degree. So we click mode right here and make sure you're in degree. That's good. So then to access, we can go back to second and then quit. Then we're back to the home screen. I'm just going to clear everything out of there. And we're going to do second tangent. So you hit second, upper left, tangent, right, 2 buttons above 9. And you can see that we have tan negative 1. And then I'm just going to say 3 divided by 2. I'm going to close that parenthesis and hit enter. And then that tells us what our degree measure is, 56 degrees. So when we do tan inverse tangent of 3/2, we get 56.31 degrees. So theta equals 56.31 degrees. Okay. So let's talk about some notes here. Some more notes here. We've got some learning targets we want to talk about. First one we're going to talk about is standard position. We're going to divide this into 3 sections. So, standard position. It's an angle with the vertex at the origin. And one side on the positive x-axis. Other side is the terminal side. Counterclockwise. Is a positive angle. clockwise is a negative angle. Second learning target, coterminal angles. So coterminal, in standard position that share a terminal side. To find them, you either add or subtract 360. Third learning target, this was learning target 2. Learning target 3. Reference angle. Okay, reference angle is angle measure from the terminal side to the x-axis. Angle measure from the terminal side to the x-axis. Learning target number 4. That's where we got into our right triangle trigonometry. We were given some distances on the coordinate plane. So we want to use the given point and make a right triangle starting at the origin. And then we want to label the reference angle theta. Okay, moving on. There's our 4 learning targets, 1, 2, 3, and 4. Now we're going to do some check for understanding. So looking here at the first one, find the reference angle for the angle shown. So we have an angle of 640 degrees shown here, and we're going to try to find the reference angle. So we're looking at the 640 degrees to find a reference angle. Looking up here, we're gonna go back to the terminal side, from the terminal side to the x-axis. So We're going to start by subtracting 360 degrees. When we do that, we end up with 280 degrees. So if we draw 280 degrees, we're starting here on the initial side and going to that terminal side, and this is 280 degrees. So if we want to figure out our reference angle, right, we're going to go back to the positive x-axis, so we're going to go back right here. So to figure that out, we're going to take 360 and subtract that 280 degrees. When we do that, we get 80 degrees for our reference angle. Moving on to number 2, we want to give a coterminal angle for the angle in number 1 that is less than 640 degrees. So to figure out an angle less than 640 degrees, we are going to take 640 degrees and subtract 360 degrees. 640 minus 360 is 280 degrees. So that is an angle that is less than 640. Greater than 640, we're going to take 640 degrees and we're going to add that 360 degrees. When we add those two together, we get an even 1,000 degrees. Again, an angle that is greater than 640. If we want to get to a negative angle, right, when we subtracted 640 minus 360 here, we ended with 280. If we want to get a negative angle, we could subtract 360 again, and then we'll end up with a negative angle here. So we'll come back and start with our 640. We're going to subtract the 360 first. That gave us a 280. Then we'll subtract the 360 again. When we do that, we get negative 80 degrees. Again, negative angle. Okay, number 3 here. We have a point at 6, negative 8. So we're going to draw in our triangle. Over here we have 6. And then we're going to go negative 8. We're going to draw back to the origin. So our right angle is there. Theta is always at the origin. And we're going to answer our questions here. We want to draw the angle on the axes. That's what we just did. We're going to write the sine, cosine, and tangent of the ratios of the angle. So we need to figure out our hypotenuse here. To figure out that, we're just going to use Pythagorean theorem. Pythagorean theorem, we're going to do a squared plus b squared equals c squared. Our a here is 6 plus the b, which is negative 8. That's going to equal our c squared. So we end up with 6 squared is 36. 8 squared is 64. Well, negative 8 squared is 64. Negative 8 times negative 8. Again, do not forget those parentheses. That gives us c squared. That's 100. And then we can just take the square root. And we know that our hypotenuse then is 10. So if we want to identify sine, cosine, and tangent from theta, so remember sine is opposite over hypotenuse. cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So when we're looking at theta, the side opposite of theta is -8. The side adjacent to theta is 6. If you get a fraction, you can reduce as we did here. We're going to divide top and bottom by 2 and reduce that fraction to -4/3. You always have to reduce. Looking at cosine, we have adjacent. So adjacent to theta is 6. The hypotenuse is 10. Adjacent is 6. Hypotenuse is 10. We can divide top and bottom by 2, and we end up with 3/5. Looking at tangent, tangent is opposite, -8 over adjacent, 6. Which we can divide 2 into top and bottom again, and we end up with -4/3. So there we identified sine, cosine, and tangent from the angle. We want to figure out how many degrees is the angle. We can choose sine, cosine, or tangent. So I'm just going to choose cosine. So if we want to figure out cosine theta, we know our cosine here is 3/5. Again, the only way to switch places between the 3/5 and the theta is to do inverse cosine of 3/5. That'll give us our theta. Go back to the calculator. And we're going to go second cosine of 3 divided by 5. And we get 53 degrees. So our theta here equals 53 degrees. So if we take 360 minus the 53 degrees, we get 306. 307 degrees. So that's what this angle is right here. That's from the initial side to the terminal side. That would be 307 degrees. Draw that in. Okay, a little bonus for you there. All right, that is it. Good luck on your homework.